helical piles, steel helical piles, wood columns, wood frame, like preserved wood foundation. These are, well, in the case of wood, that is explicitly in the prescriptive building code. You can build a code-compliant house, Part 9 building, with a preserved wood foundation. That's no problem. Helical piers are not explicitly in Part 9, but they are, yeah. They're not explicitly in Part 9, but they're common enough, and there's a load rating that is given at the time of installation. So most building officials will still require an engineer to oversee, but it's rare that you have to submit an alternative solutions proposal for a helical pier. The kinds of rubble trench and earth bag foundations that these guys are going to present on pretty much require an alternative solutions proposal. That's going to have to happen.
I haven't mentioned this yet, but I just designed a rubble trench for our upcoming build this summer, and they didn't ask for an alternative solution submission. So
that's great. I don't think they're taking a significant risk because there's no problem with the rubble trench being Part 4 compliant.
No.
It's just not listed in Part 9.
What's Part 4?
Part 4 is structural like everything that isn't 600 meter or smaller, 600 square meter or smaller residential kind of thing. If part of that alternative solutions proposal is claiming that it is a Part 4 design, then yeah. On the other hand, that's sort of a chicken and egg thing. If you're doing a Part 4 design, you shouldn't need an alternative solution proposal. You should just say, this is a Part 4 design, and I'm designing according to best practice of the Canadian Foundation Engineering Manual, the Canadian Geotechnical Society. But then you need an engineer. If you have BCIN, I think you should be able to put that alternative solution proposal together. Whether they'll say yes or not, they're more likely to say yes if it's got a stamp on it, because the stamp implies that there's liability insurance, and then that liability just shuffles off of them. I would say that a rational building code official should look at your proposal and say, yeah, this is not unreasonable. But if they are rational but risk averse, if their counselors or the municipality lawyers have told them, no, don't ever take on any liability or whatever, then they might just say, look, you got to do this. So the one thing I wanted to touch on, well, there's so much to foundations, there's so much interaction between a structure and its foundation. One of my advisors back when I started and didn't finish a PhD, he's an architect and a great guy, and he didn't take it too far because he saw the limitations, but when he first heard about people using shipping containers as a building component, his first thought was, right on, you don't need a foundation. That thing is stiff enough, you just put it down. Done. And that was, for him, that was just like, that's awesome. And they're made to sit on 4 points. You can, put them on the ground. That you should provide firm support at the 4 corners. But that's an example of a structure that is completely rigid. It does not need a rigid foundation underneath it. That would be really, really redundant. Other structures are kind of semi-rigid. You put sheathing on a stud wall, maybe you have a double plate at the bottom, you got a sill and another plate. That's going to behave somewhat rigidly. Like, you don't technically have to have a footing underneath that whole thing for it to span. If you just supported it on 8-foot centers, say, it probably wouldn't. I'd have to run your numbers and see what load you're putting on it. But chances are you would not need a continuous support under that. It's semi-rigid. We used to, in timber frame, have big sill plates because we were setting barns on rubble, or uneven stone, and most timber frames now that are sitting on a regular floor deck are more like marionettes. The posts have to sit on something, but it's not an integral part of the frame. So those two styles of timber framing would lead to different styles of foundations, or whatever you're going to put underneath that. That's one set of thoughts, that there's this interaction between the structure and its foundation. And the other thing I wanted to just talk a little bit about how soil feels load. So arching is a huge, I mean, it's not, technically speaking, that isn't quite the right thing. If there was another geotechnical engineer in the room, they might come up here and slap me. But for all intents and purposes, here in the room, we can think of soil as having arching behavior, most soils. Soil's strength is dominated by confinement. It has strength laterally when there is more soil. So you will have a problem if there is a hill. There is some distance that you need to stay away from that hill to have confinement to give your soil strength. And to have that arching effect, so here's a real classic, this is spread footing with a frost wall above it or whatever. But this is just the class. This could be an earth bag, and we have earth bag, and we've widened the bottom. We've got maybe 2 courses for whatever reason. We want to spread a load. If that distance is B, then at 2B down, we're going to have somewhere between a third to half of the load being felt by that soil. The rest of that load is going that way. And by 10B, it can't tell that you put that footing above it. It has no idea. If you go with like a ballast style, which is really rubble trench, is a contained ballast style foundation. So ballast, when I say ballast style foundation, the classic is a railway bed. These are supporting enormous dynamic loads, and it's just gravel and wooden sleepers. That's it. And then they kind of attach, but all those rails that whole thing is very flexible, but it can take massive loads, and they don't even confine that thing. It's just at a slope, right? You can see ballast piles that are 30 feet high. They'll be pretty wide at the bottom, but the soil underneath that thing, another 30 feet down, has no idea that a train's going by. It's because it converts everything to these lateral loads. It just spreads it out, which is a little counterintuitive to a structural engineer wants to keep all of the forces inside their structure. And if you do graphic analysis, stability analysis, like non-numerical analysis, you literally have to keep force vectors within the bounds of the elements that you're drawing. That's how an arch can be designed. There's a lot of ways. It's so that we think, okay, it's got to be contained. Once we get it to the ground, it's going to go. And that's a great thing. But it's not going to do it without deflection. It's not going to do it without displacement and without a long-term displacement, which we start to call creep, if it's sustained load and you have a sustained deflection. The kinds of foundations that these guys are talking about will definitely, over time, they've got a good chance at creeping, depending on the material that's being used. If we've got a good crushed granular where you've got a lot of interlock and you do a good job of compacting at the time of installation, there's a very real possibility that you can exert more pressure when you're tamping than the building that's going to go on there will exert. So I think without further ado, I'm going to say let's look at some of these examples, and these guys can give you...
All right, actually, that creep is a great segue. I got a good story about a friend of mine who is also a timber framer. Went to do some timber framing over in the UK. And here in North America, we timber frame to very tight tolerances. We often cut our joinery to 30 seconds, and a lot of Europeans actually come over to do timber framing here for that reason. He goes over there, and he's on a raising, and he goes to look at the foundation, and he comes back to the foreman, and he says, you're not going to want to hear this, but this foundation is like a ½ inch at a square, but even worse, it's like an inch at a level. And the foreman goes, right then, take a look around. You see a building here that's level and plumb, right? It'll fit right in. Yeah. Right? So which is to say that the creep is not necessarily an end game, like it's not necessarily failure mode, right? So, as witnessed by 500-year-old buildings over there.
Right. Yeah, but I mean, we all see it with poorly done backfill beside a classic
concrete foundation wall. Over time, will settle. That's not creep yet. It'll just settle, and then you've got a bad detail. You've got water potentially running in beside your foundation. That's just poor detailing. So there could be consequences.
And so this is what I find interesting about, in particular, earth bag foundations. If you had some of those conditions with a more brittle foundation type, like a concrete, and you were experiencing some of those site settlement conditions, then you might have very serious problems broadcasting through your structure. Right?
Yeah.
It might be safe to say. Whereas a foundation like these earth bags is a little more forgiving, which isn't to say that we're designing for that to occur, but it's just to say that I like forgiveness as a concept.
Foundation.
Yes. Yeah. So I've done a couple earth bag foundations recently. It's my first foray into it. Like I said, coming from a timber framing background and being very quality oriented and oriented towards building for longevity, I have to say I was a little gun shy with respect to earth bag foundations. So I'm trying to open up new understandings for myself, and this was an opportunity to do that. And I can say that I'm a fan. This is a project. This is on Saugeen First Nations. It was a volunteer project for an elder who had very little money, particularly when it came to the foundation. So this bungalow was donated to him. His house had burned down, and he was essentially without a place to live. And someone had donated this bungalow, which wouldn't be my first choice, but free is always my first choice. He was going to receive this bungalow, but had no funds for a foundation. And I had been working around the corner on another project that I'll show you in some other slides. And his sister, who was an elder in the community, came and said, look, can you help us out? And I said, well, I'm pretty busy, but this isn't rocket science, so I can show a couple people how to do it. I can spend a few days on site, volunteer my time, and then within no time, I'm sure that crew can take care of the task. And that was indeed the case. So that's one of the things that I like about this approach, is that it's very accessible and very inexpensive. This entire foundation was about, I'm going to say, about $400 in materials. This is a bit of a stem wall. The height was really governed by the fact that this building was being moved onto the foundation. So we had to accommodate them being able to get the I-beams out from underneath of the house. So therefore you get the height. Otherwise I would have probably kept it lower to grade. But this still worked out pretty well. And it looks like my slides are a little out of order, so I might be jumping around a little bit. But here you see the pockets on the front. These are just to be able to remove the I-beams. They'll be framed in and filled in. You'll see in some further photos, like this all gets outsulated with a Roxul, and then so these will just get filled in with Roxul. Okay. Framed in. This is another one closer to grade. In this case, it's only 2 bags high from grade, but what you don't see here, you'll probably see on some other slides, is the framework above, which will be filled with a straw clay, and then on this particular building, it'll have what I call a skirt around the building, which for splashback protection on the straw clay, and that skirt will then come down and cover the earth bags, and then the backfill will go against the skirt. And so that skirt drains right into the aggregate below. If you ever look at details of stave churches, it's basically the exact same idea. So these stave churches were like a timber frame church with a sill plate, continuous sill plate, on essentially a cobble trench, and wooden planks draining right into the cobble. And, it stood the test of time. That's my favorite code book, is history, because I look and see what's worked. And if it's worked, then it's probably a pretty good starting point.
We don't see the ones that fail.
That's right, yeah. Another thing to mention here is attachment of the frame to the bags. I was done with trucker straps, a combination of trucker straps and Simpson strap material, which, got to say, this one being my first one, Tim can attest to the phone call. I was like, by the time we have this framework up, I've got much more bracing off. I got places I can brace down to a subfloor or, whatever. And, this is all just kind of floating in the breeze, until we get our roof set. And so that was a little bit of a thing I had to get used to. It's just like, I mean, I knew like that, yeah, it'll stiffen up when we get the roof on, but still, it's just, I'm not used to experiencing that condition on site.
Yeah, sorry, is that just two bags sitting on like a rubble trench type thing?
Yeah, so in this case, they were very sandy soils, and so in this case, the rubble trench is actually like the entire footprint of the building is with this aggregate, but then that footprint slopes off to free drainage, drain to daylight from there. Gravel, it was probably 18 to 24 inches. Yeah, so 24 inches around the edges and 18 inches in the middle, yeah.
Oh, okay.
Yeah. So all compacted in layers, I should say. So like, you want to get your gravel down, compact it in generally 8 to 10 inch layers, right? So then that ensures that good locking action of the aggregate. Yeah, 3/4 inch clear, yeah.
And in the middle, you could use crush depending on what you're going to put above it, right? But on the perimeter, one of the big secrets here is to avoid frost heave is to just have things dry. Because frost heave is just water freezing and expanding. And so frozen gravel that doesn't have any water in it is the same volume as hot gravel that doesn't have any water in it. So just keep it dry. But I mean, it's easy to say.
Which means drain.
Which means drain.
Yeah, which means clear.
Yes,
exactly. No fines.
Yeah.
So
Right?
3/4 inch
Clear for that
and then
perimeter.
3/4 inch crush.
For the middle, if you
Although
what you're going to do.
Although in this case, I just went clear through the whole thing.
Yeah, it starts to complicate things sometimes.
Yeah.
And that strap goes all the way through and around on the other side, and you did the same some time on the other side, just clarifying the detail?
Yes, that's correct. And this is great. When you remember to put these things down first, you lay them out. It's real simple. It's not as simple when you forget to put one down. Because you got to drive it through and be careful not to drive into the bag, and it can get sketchy, but it can be done. So, I'm speaking from experience.
You didn't need to use a weeping tile system?
Yeah, around the perimeter. So this is basically, if you imagine a 40 by 40 structure, that's what this is. I might have a larger photo later. It's basically 40 by 40, the entire footprint excavated because I'm in very sandy soil. And the perimeter of that excavation is down to about 2 feet with the weeping tile, and then to about 18 inches in the middle. Yeah. So that's the other foundation. Yeah, no, they're as continuous as practical is kind of a good rule of thumb. So here, rather than like a poly vapor barrier, which is prone to tearing, etc., I just basically used dimple mat underneath the house there. And this foundation it'll be conditioned space, right? It's treated as conditioned space, not as a crawl space. And this is just something that we did on site. This is not really, this is achieving two things. One is this kind of chinking gaps and holes as a result of the geometry of the bags themselves. And the other thing is it's just kind of getting a layer of mud on there to help protect from UVs until we've got it finished with cladding material. Because really that's the biggest enemy of earth bag foundations is ultraviolet radiation. So I just kind of came up with that little solution on the fly just because we actually had a lot of volunteers on site and I needed to make some work and
yeah. Donnie Kiffmeyer and Khaki were talking about how actually the bag can be removed if your mix is ideal. Mm-hmm. And they actually had a client and she burned the bags off of her her walls when they were done. She just didn't want the plastic there, and she literally torched it off. So apparently, if you have an ideal mix, the bags then become sacrificial.
That's right. So, which brings up the point, what do you put in the bags?
Yeah.
Thanks for that prompt. Yeah, so what do you put in these things?
If you're not going to take the bag away,
you
can put just about anything in them.
Yeah.
Just not organics. But sand?
Road base. Road base with metakaolin. We used as an additive.
Sand stiff.
And that metakaolin is, as an additive, that's what really starts to then give some stiffness to the material that you're filling the bags with, yeah?
Yeah.
So, yeah, METAKAOLIN.
It's a calcined clay. It's a byproduct of the.
It's a type of clay.
Yeah, it's a byproduct of the production of Pour River, which is an expanded glass aggregate. So they're crushing they're taking recycling glass, crushing it, and then firing it in a rotary kiln to pop it, kind of like Rice Krispies. But their lubricant in that drum is clay, dry clay, that then is fired at, it's somewhere around 800 C. So it's not as high, there's embodied energy in this stuff, but like a lot less than concrete, than cement.
And it's a byproduct.
And it's a byproduct,
Yeah.
yeah. So there's some economies there. If you mix it 1-to-1 with lime, you get a great pozzolan for more traditional, wetter, concrete kind of mixes. But if you just dampen it, put it in something like this, it will set up, we're
Where
talking,
do you get that?
Pour River is in Innisfil.
Okay.
It's a manufacturer of expanded glass aggregates.
Yeah. The mother company's from Germany.
Kaolinite is a type of clay.
Yes.
There's Montmorillonite, kaolinite, and so and many others,
Yeah.
but those are three primary ones. But I'm guessing that's the type of clay that they're using for their
Yeah.
lubricant, right?
Yes,
So,
exactly. And
yeah.
it's a very common one. It's the least expansive of the clays. It's very common for pottery. So kaolin clays are, yeah.
So, in terms of the compressive strength of if the bag is sand, what's the compressive strength versus filling the bag with, say, rammed earth? Is it
Yeah,
similar?
so you're going to have less, and it's going to be more flexible over time. So so an ideal rammed earth mix will have a blend of aggregate sizes going all the way down to clay, and in that case you would technically be able to take the bag off, but I don't recommend that personally. But that's but if you took it off and then plastered it, maybe. I mean, you're still going to have a tensile layer. You're just not completing the containment. But for raw strength, pound for pound, money for money, something like Road Base with a bit of that Medicaid, yeah, you're going to get a really strong, very strong.
And I would, I mean, like to the point of getting rid of the bags, like I would say, to me, like in almost every building system that I employ, I'm looking for redundancies of some degree, right? So whether it's structural redundancies or, I mean, to a point, right? Like obviously there's a point of diminishing returns there, but.
This is good. This is like what I'm wrapping my head around is that the bag is actually structural.
Oh yeah, so
You can chuck.
you're mixing until you add that metakaolin or some other binder.
Awesome.
You
Yeah.
are mixing a pure compression, like zero tension capacity, with all tension capacity, and you're getting the whole being much greater than the sum of the parts.
Great. So you could do just gravel bags.
Yes. Yeah.
Yeah.
Yeah, you could do 3/4 clear. It's just as it sits, and if you don't touch it, it'll have that strength, but it can move.
Well, I mean,
You get low reversal, and
this is a gravel bag, essentially.
yeah,
It's just contained by earth instead of,
yeah.
instead of a bag.
But it's only got capacity that way. The contained bag ones actually they'll have some uplift capacity. I mean, we're going to rely on it.
I think I can see it. I think you're on that. Is that barbed wire?
Yeah, so barbed wire between the courses, yeah. Give a bit of friction between courses, yeah.
Yeah, it's classic earth bag detail.
No, so these are some wider shots of that larger one that I showed you that you saw the straps with. The ends are rolled like 6 times and then zip ties to constrain the ends. All of that is pretty basic stuff that really pretty much anyone can learn in a couple of days on a job site. So where I would typically come to a job with the foundation having been poured by subcontractors. At this point now, I'm becoming much more involved in foundation design and prep. And as such, it's leading me into territory where I'm realizing that there's a lot of opportunity to be found by responding to a site. You know, you don't always have to go to 4 feet. You're not always going to have a soil that will contain a trench, or you're not always going to have, so you always have to kind of respond to your site and what type of building you're building. That's how we end up with like basements, because people just think that's what a foundation is, right? But anyway, but those are just a couple photos of a couple of projects that we did last summer. So in that sense, like this, but this does kind of lead towards, and vice versa, the cobble trench thing, because it's similar in that it's starting to look at and closely examine why we build foundations the way we do, and ask the question, do we have to always have the same response every time? And for conventional builders, they are more apt to just use the same solution all the time, because once they've got it figured out, it's already in code, they're making money off of that. But that doesn't always work in every situation. So, you know, I've always known like, oh, you know, yeah, concrete bad, I'm not really interested, but, you know, kind of necessary evil. And as I said, I always want to build for longevity, but at a certain point, what's the point in building for longevity if we're not going to be here to enjoy those buildings, right? And what I've learned recently is that the second most consumed resource on the planet behind water is concrete. And that blew my mind. I thought that was like hyperbole, and so I cross-referenced it with a few different articles, one of which was from MIT. Yeah, I'm not one of these science deniers, so like if it's coming out of MIT, I've cross-referenced it 4 different places, and I had to buy that article. So if that's another good question. If you got to actually shell out money for the article, then you know you're probably at a credible source.
Do you have any rules of thumb for calculating the labor time on these? Like if you're doing a budget or trying to, you know, like compare different options.
Right. That's a great question. I don't have that analysis yet.
I think in the Earthbag book, there's some, and that you could probably extrapolate.
Yeah. I mean, there's people out there with a lot more experience with this than I have, but I'm just here to say that as someone who was skeptical, I am now a convert. Yeah. So you could become one too. Hallelujah.
When you have, let's say it's not totally level.
Yeah.
How do you get that so that it's dead level?
Yeah, that's great. Well, that's another beautiful thing about this, coming back to that concept of forgiveness. As you tamp this material, as you fill it and tamp it, you're constantly checking for level. With a transit, you can use the old school transit, or you can dee-dee-dee-dee-dee. And so you just dial it in as you go.
So then you're not getting, let's say you got a bit of a low spot, so you're not tamping that quite as hard as something decided. Does that affect the...
Well, you are, but you're putting more in, you're putting a little bit more in, right? And truth be told, you're also checking everything with a transit while you're compacting the gravel layer as well. So by the time you're compacting your gravel layer, you're pretty close, plus or minus 1/4 inch. So you're really chasing out a 1/4 inch. At the end of the day, that's the job of trim as well, which is to say that... Which is to say that the whole job of building is chasing out tolerances through the whole process.
Sorry, I think you said 2 feet deep. That's not, the banks don't go 2 feet deep.
That's on this site with these soils. Yeah, that's not like a gold, you know, that's not like a...
No, if you've got soil that will hold the trench, and we're going to see an example, it is best practice to get to frost depth or lower. That you should shoot for that. But that was not this site. This is just a giant beach.
Yeah.
Yeah. On Green Building Advisor, you know, the articles that you could add in flare out.
Oh yes, absolutely. Yes, this is you could do this as a frost protected shallow foundation and do horizontal insulation. Absolutely. And you can put pipes in the ground underneath this thing and there's a lot of things you could do with this that aren't just... And
that's a great way of, this is one of the only sites I've worked on probably in the last 20 years where despite torrential downpours, I never have mud on my boots, which tells you a lot about the soil that you're on. So, it's a very rapidly draining site.
I feel like foundations, most of the time, you're selecting from a list of bad choices. It's really hard to make good choices when it comes to foundations. It ends up being an exercise of compromise and trying to use minimal cement, essentially. We now commonly know cement is responsible for somewhere between 4 and 8% of all global greenhouse gas emissions. It's a big player, and a ton of cement equals a ton of carbon. So there's good reasons for really trying to minimize our use of it. We only have 11 years. So, as it turns out, I've been working on buildings with rubble trench foundations kind of from the beginning. That wasn't really even on my radar. I wasn't really thinking about that until I got these slides together the other day, but I started building in 2004 as an intern with Chris Magwood, and I don't have a slide of it, but some of you probably know the house that Chris Magwood built for his mother. Have you seen that with the nice exoskeleton? That was a rubble trench foundation, and I'm just going to spit out lessons learned as we go here. So learned a couple things on that one. For one, it wasn't great digging. It was Madoc. There was a lot of rocks. So one really nice thing to have for a rubble trench foundation is a clean, consistent trench, just to make your life easier. Not to say that you can't do it, it's just more time consuming. So there was a lot of big rocks in the way, so that just made it extra challenging to install insulation on the inside of the trench, which is what we were doing at the time, which now we've moved away from, thank goodness, because we were using Roxol drain board insulation to line the trench as an interface between the ground around the trench, which is going to continue to freeze and thaw and heave and move, and the rubble in the trench, which we don't want to move. And for various reasons, we defaulted to Roxol drain board, quite intensive of a material and expensive a material, and now we use a geotextile liner. So there's some lessons learned there. And then also make sure you time your excavation so that you're excavating and then you're ready to fill that day or the next day. You need to leave enough time to get a drainage inspection. The building inspectors will come out and they'll go, "Where are your footings?" Because you haven't put any footings at the bottom of the trench and they haven't closely looked at the plans. So you just need to leave enough time to get an inspection, and then you want to fill your trench right away, because what happened on Sandy's rubble trench was it rained for 4 days. We got crazy rains in 2004. That's when the Peterborough flood was. And then we spent just as long shoveling it all back out again. Really pretty defeated by that. So then the next year was sort of my first solo project, and it was building this canteen washroom facility at the Madoc skate park, where I did a rubble trench foundation as well. How many pictures of that? Because, we'll get to other trench pictures. So going from small to massive, skip ahead, this is now 2013. We built this house and we did a Durasol foundation under a third of it, and then rubble trench for the other 2/3 of it, and learned some key lessons there. One parameter for a rubble trench is it works best when you have a relatively flat site, and as we know, there's no such thing as a flat site. All sites have some slope to them, and so this building was 70 feet long from one side to another, and there was 5 feet of difference in grade from one side to another. So that gets extra challenging, because what we had to do was basically do a gravel fill on this side up to 5 feet to get to a level where we could pour our footings. So that becomes very expensive. That much clear stone is very expensive, and the trench is way down there, and then on top of it there's this other huge bed of clear stone. So environmentally, it still would most likely win out over a more conventional concrete-based foundation, but cost-wise, it may not once you're using that much clear stone. And also, interestingly enough, going back to visit this project a few years later, there's actually a crack in the outside of the wall, exactly where the switch in the foundations is. It was the homeowner, he brought me over to show me the crack, and standing there looking at it, and he goes, "Wait a second, this is exactly where it goes from basement to rubble trench." I was like, "Oh yeah, right." So there's some settlement happening. So this is another thing, like with all foundation design, the year before you build, you want to do test holes and get the excavator to come out and dig 4 test holes, maybe at the corners of your footprint, so you know what you're going to run into. This is a site-specific foundation. It's not going to work great for all sites. If you're digging and hitting water, it's kind of challenging for any foundation to get started. We've run into that, and we've had to pump it out, and keep pumping and get our footings in real quick and get the drainage in. As long as you can dig the trench and get the drainage in, you could. It's just going to be a little bit more challenging and mucky. One of the things is you have to put a drainage pipe at the bottom of the trench, and then that drainage pipe has to go from there to daylight or to a dry well, which I can't speak on because I haven't done that. If the geography is such that there's no daylight for like kilometers or something, I guess you could come up with something else.
For instance.
Going back to your metaphor with the train bed, though, however, obviously there are train beds, and I keep trying to reassure myself because I encounter these site conditions sometimes as well, and I think in the train bed moving through a wetland, for instance.
Yeah.
Can you speak to sort of porosity of the gravel and what relationship that has to expansion, contraction, and load bearing?
You want to be above. You don't want any material finer than a 2 millimeter diameter grain size. If you've got that or lower, you will have capillary action. It'll draw up moisture, and there'll be wetting, drying curves. You'll have matrix suction. There's a lot of things going on that could be good, but if you're going to be in that condition, you want drainage. So you want that thing to. I mean, the bottom of it will be wet and will be weaker. Been on railway beds that go through swampland. They move over time. As far as I understand, that is because they lack confinement. That swamp down there will just keep taking
undermine over time.
Yeah. If there's 2 millimeters on the low side, is there a cutoff on the high side in terms of size?
Well, I mean, not really. Your human scale to work. I mean, at times I've spec'd 2-inch to 4-inch to try and get a really strong, really robust thing, and then the students or the workers just say, "What the fuck? Like, this is really hard to work with." I would say it's more limited by the workers, by ergonomics, but there are 6 and 7 story brick masonry buildings in Winnipeg sitting on just limestone, large chunks of limestone rubble that they just threw into the clay and sat, and then slowly it turned into stone masonry and then brick masonry. But the bottom 3-4 feet is just big chunks of limestone in a ditch,
Okay, so that's just the other side of this building. So this is that rubble trench that I was just talking about. So we're at the 70 feet away mark, and we're looking back. So this is that huge bed of gravel. So like the trench itself is like nowhere to be seen. It's down there. Conceivably underneath where we're putting our forms for the grate beam, and you can see the edge of the Duracell foundation over here. So Tim is an awesome engineer, and he said, it's you guys can do 2x4 grate beams. So grate beam is basically the same as a footing, but at the top of the trench instead of a footing at the bottom of the trench. It's very, very similar. It has 2 courses of 15M rebar, and you form it and you pour it, and this is where you get to a level on a rubble trench foundation. Basically, we aimed for level with the clearstone at this point, and then you can really dial in your level with these forms. There you can see our forms poured. This is a pretty crazy building with a round silo here, so we're laying out the plates for that. Okay, so this is the barn greenhouse chicken coop that I'm currently building, and so I'm going to take it step by step for the next few slides. So this is first step, like layout, and I always just love these pictures, so I feel like I need to include one. I just like the fluorescent paint and the colors, and yeah. So then the excavator comes along and digs. So here's another lesson learned, that you always design for a 2-foot trench, right? Like that's what's on the drawings, this like perfect 2-foot wide trench. But it doesn't go like that with excavation. Excavators do an amazing job, but it ends up being 30 inches. And if you've only budgeted for 2 feet, it ends up being another few loads of gravel, another few $100 out your pocket if you made a quote on this foundation. So always account for like more clear stone than you think you're going to need. So this is an example of a perfect trench. Man, these trenches were so cool. I kind of wanted to just put a roof over top at this point and like have friends over and hang out in there or something. Yeah, it was so cool. And they just went for so long, and it was like concrete. It was so strong. It's awesome. So it's a pretty ideal situation for a rubble trench. So here's the geotextile liner that I was referring to. I have a slide in here, I'm pretty sure, of Jen and I doing a rubble trench foundation where we used carpet as the liner. You can totally do that, and it was really fun, us going around and going to carpet stores and hitting up their dumpsters. And I have this hilarious picture of Jen like lying on the used carpet in the back of the truck. But I learned on this project, in the roundhouse that I showed pictures of last night, I pumped my clients up to go get used carpet, and they did. And then, of course, it's one of these things in building. Building is so overwhelming. When things get hard, usually that's the first thing to go. So in the end, their used carpet is just kind of sitting there molding, getting all nasty, and they returned to another alternative, which was geotextile liner. It's 7 feet wide. It does a great job. You have to buy it. It's not as sweet as used carpet from an environmental point of view. So this does a great job in that it's 7 feet. So it's kind of like the right dimension for a rubble trench, because Tim typically specifies a 5-foot deep trench. So we're going like a foot below what grade says is where we should be for a frost protected foundation. Yeah.
So we're just adding a little bit of capacity there.
At belt and suspenders, as you would say.
You put it along the bottom as well as the side?
No, so just the sides. I use sod staples to hold it there. Super easy, goes sod staples, like, so here's what it looks like once it's all in. Then comes the drainage pipe, so we're using 4-inch perforated Big O with a sock on top. At this point, it leaves the trench and it switches to solid. And then 250 feet away, it gets to daylight. That was expensive. Yeah, so better probably would have been like a dry well closer. Lesson learned. Then this part's awesome. You get to call Castle Ridge Concrete and say, we're ready for the slinger. Tim has specified that we need 3/4 clear stone, 6 inches of it over the Big O, and then we can switch to 2-inch to 4-inch clear stone. But loads are big, so we end up doing sort of the first load, or 1 load's worth of 3/4, and then switching to the bigger aggregate is super great, because one of the biggest luggers about a foundation is getting above grade. In a conventional foundation, it feels like so long when you're down in that hole. With this, it goes so fast. Like in a day, this gets filled up. And so Stone Slinger makes easy work of that. And then we compact it in 1-foot lifts. So the Stone Slinger just waits, run around with a compactor, and then put in another layer. So in case it's not obvious, the sort of principles that we're working with here are drainage and compaction. Like people are like, well, why is this not going to move? 2 reasons. It's draining, so the water is always leaving, being drained away. And we're making a really solid base out of clear stone, which in and of itself is self-compacting.
Yeah.
But
we're running it in there in a situation where, again, we have confinement. So this stuff wants to get away, but it can't. So you can actually get a pretty good compaction on the clear stone in a trench.
Oh, sorry. Yeah.
So I've done a rubble trench foundation, and we added another principle, which I wonder if it is a redundancy. So we assumed that it was possible that even with a drainage plane and a drainage layer, and that it's possible to have moisture still get in. And as a redundancy, we always created a dynamic where the rubble trench itself could not freeze. And therefore, we put insulation on the outside of that. That's obviously not what you're doing here.
I would say that's best practice, would be to do that.
I think you've used the word belt and suspender to describe that before.
Yeah, for sure.
Yeah.
And it would also, this is a chicken coop. No offense to the chickens, but if you were doing this for a house, and like I said, just threw out there earlier, you might throw some pipes down there so that you could have a brine loop running to preheat or pre-cool intake air in your ERV or something. It would be very, very wise to then insulate, and then to insulate that whole perimeter and then have all that mass underneath your home, and over the course of 10, 20 years, that stuff, at the very bottom, it will be whatever temperature things are, but you can heat and or cool with that mass all the time. It'd be a great, the notion of earth coupling foundations in biobiology is about, you know, resonance and health, but I think there's a big component that we could gain by sort of we're digging it anyway, it's sort of the poor person's ground source. I hate the word geothermal. Geothermal means steam from like lava, like Iceland. They've got geothermal. We don't have geothermal. Little rant there.
Hallelujah.
We have ground source heat pumps.
Preach, brother.
Anyway, that's pet peeve.
So lesson learned right here. We bought the stones level with the trench, and then the site is sloping. There's 1 foot of difference from this high side to this low side. And then it made for tricky forming and these tapered forms to get the top of the forms to a level, which was just time consuming and more concrete, as opposed to we're doing a rubble trench this summer on the house that we're building, and we're going to when you get to a level with your grade beam, you can do just 1 course of ICF block, because essentially the grade beam is coming to grade on the high side. So then you can just go 1 foundation block above that and then start your walls. Instead, what we're going to do is we're going to make the rubble level, like as close to level as possible, and then go with an even 2x6 form, so 5.5 inch grade beam, and then go 2 inches of foundation block, and the difference in grade will be able to slope around those 2 foundation courses. Is that making sense? I have a cross section, we can look at that. Because this is time consuming to build taper forms. You'd like to avoid them. Also, another challenge with rubble trenches is you don't really have ground to stake to very easily, because clearstone doesn't take a stake very well, so I ended up having to rig up these Duracell blocks to hold my forms. The lesson learned there is make your top of trench level, and then really dial in your level on your grade beam to avoid tapered forms. I think the product is like V70R. It's readily available from Timbermart and Home Hardware. It's just an interface. We kind of realized we didn't need to use the insulation there,
you didn't need, But it's also preventing fines from getting into.
Right.
If we had too much fines getting into our rubble trench, then we would start to hold moisture, and then we could very easily get to frost heave.
In this case, I felt confident with the technology. We haven't seen issues from not doing a skirt. That's more of like a settling difference from one foundation system to another, but it's not like we're seeing cracking or settlement issues on other projects where we've done that.
If you had a horizontal insulation skirt, that would allow you to not go as deep. Yeah.
They're kind of annoying. Like, they mess with your grade. How far down are they? They're tricky. It's not. Usually mid-foam, we wouldn't do foam, but it's still Roxol, it's expensive.
It's a design feature. If you're incorporating landscape or patio or some kind of element around your building, maybe you're doing a double earth bag strip with planters or your insulation and then pavers, something like that. I think it could be, but it's got to be a durable situation, or I guess you could have a deck, whatever. But it's a chicken coop in a greenhouse, and people are going to be coming and going all the time, and it's not going to have hardscape around it. So. And
you could also somewhat reduce that risk by like a deeper grade beam, right? Okay, so there's the one course of Nexem, formerly Duracell blocks, laid, and those are pinned to the grade beam, and they also have one course of rebar in them, and then burn on top. Yay. Roundhouse, I showed that last night. That also has a rubble trench found, basically the same system. Here's Jen and I's. Really enjoyed using these Simpson concrete screws. They work really awesome. And here's Jen and I's rubble trench carpet adventures. So this was a no concrete foundation. So we just had these big rocks. I was about to say we put big rocks on top. No, we didn't. We had the excavator put these big rocks on top, and then we put our beams across and then framed a floor on top. That's the only time we've not had a zero concrete foundation. It was also a unpermitted building. How do the numbers compare? We're going to be building a house this summer, and I costed it out both ways, doing a 5-foot Nexem wall on a footing or a rubble trench as just described. And the Nexem wall came in at $33,800. The rubble trench came in at $26,600. So my clients chose the rubble trench. Seems like a no-brainer. And this also included the engineering by Tim, and also my clients are also on board for reducing our carbon footprint. Along those lines, I want to make a case for us builders taking the time to do the math and not make assumptions about what is going to have the lowest embodied carbon based on we know. For example, as a straw bale builder, I could say, yeah, my bale walls are definitely going to have the lowest embodied carbon. But actually, when you sit down and do the math and you factor in that plaster skin, comparing it to double frame cellulose with drywall and wood siding on the outside, I don't think so. I think that one actually comes in a little bit less. And so Chris Magwood has made it really easy for us to do this. We just have to go pick up a copy of his Building Better Buildings, and he's done all the hard math in terms of how much carbon is embodied in the materials that we're using, and then it's just a matter of sitting down and doing some calculations. So this is the calculation that I did for the rubble trench foundation of the barn greenhouse chicken coop. So basically, I came up with 800 kg of carbon for the one course of Durasol, 834 carbon for the grade beam, and then 119 kg for all the clear stone that went in. So you can see the clear stone is definitely like the lowest of all assemblies. So that totaled 1769 kg. If I had done the whole thing in Durasol, it would have been 4975 kg, so a significant savings there. Here's the cross section that I was referring to. So this is what we're going to be building this summer. So this is where I've revised the cross section so that it is now a rubble trench foundation. And I don't show the grade. I guess I just got lazy and I did like the grade as if it was flat. But in fact, the grade, this side is like the high side, and then it slopes down so that it's 2 feet lower on this side. So essentially, we're going to bring the clear stone to the height of the trench on this side and keep that level going across, and then put our grade beam on top. We're going to use the concrete snap ties so that that's going to hold our form, so like a little piece of metal with hardware on the outside that's going to hold our formwork upright, and then get that to a level, and then go 2 courses of Nexem block from there. Okay.